All right, so with this now, what we're gonna do is this lab is all about dealing with our raster layers. So the first thing that we're going to have here is we're going to load in our two different rasters. So the one at the bottom here is the USGS Mississippi Alabama 2020 digital elevation model, and it says cut. The one up here is the NAD 19 Mississippi Alabama 2002/2012 DEM cut. So if I put this one on, what you can see is that there is a bit of a gap here. Unfortunately, that's just part of how this data looks. So this was a composite from two different images, and unfortunately it did not match all the way across. So if we zoom in here though, what we can see is that each one of these has an elevation attached to it. So if I click on one of these, then you can see that this is 4.96. And so that is going to be the start of one of the things that we can do, right? So this is all of our elevation. So if I've got a darker layer over here, it's going to have less elevation, so negative 8.8. And if I have white things, this is going to be a higher elevation. So in this case, 40.2. So this is a digital elevation model that we can see. And so we're going to be playing around with these digital elevation models. This one is the 2021, but it looks very similar. And so we're just going to take a look at those different things to see how things have changed with the elevation so that we can sort out how sea level rise is going to impact different areas based on the sea level rise projection scenarios. Now, again, if you zoom in very, very close to each one of these things, you can start seeing that each one of those is a box, that is a pixel. Now, on these, you can also go to properties and figure out how big things are on the ground using this source layer and raster information. So this is a negative 0.0000095 in this particular case. So this USGS one is 1 meter by 1 meter. So this is taking a look at it in decimal degrees. Part of that you'd be able to see because it does not, in this case, have a projection attached to it. It is only this NAD 1983. So this is in meters. So this is in decimal degrees, which then translates to about 1 meter. Same thing with this one. If we go over here, we can do the same thing. We can do the raster information. This is 0.0003. And so same thing here. This one is in NAD 1983. So they don't match up 100%, but they are fairly close. So if I zoom in here, you can see that the boxes are a little bit smaller on this one. So you can see that each box is this area here, whereas this one is a little bit bigger across. So it's different layers will have different values attached to them. So how much they say are on the ground. This is going to give us some things are going to be more specific, some things are going to be a little bit less specific. So you can see how much level of detail you need. Now, the first thing that we're going to do in this particular case is take a look at the hillshade. So a hillshade is when we take, so this is just where the elevation is, but it doesn't really look how it would on the ground. So in this case, if we head over into analysis and we head over to tools, we can start typing in hillshade over on the side here, and it'll come up with these 3D analytics tools or the spatial analyst tools. These ones are going to essentially do the same thing though. So in this case, we are going to take a look at this one. We're going to input one of the raster. It's going to automatically put this as the hillshade. So we can change this value to maybe hillshade 2012 just to make it easier. Now, in this particular case, we are not going to adjust the azimuth or the altitude. So essentially what this is looking at is what angle the light source would be from, what direction the light source would be from and at what angle. So in this case, it would be doing it at 315 degrees and it would be at 45-degree angle. So you can also take a look at what the shadows are if you want, and you can also do a Z factor. So a Z factor is going to artificially adjust how tall things might appear on the ground to heighten out what things are going to look like, basically. So this is stretching things artificially in the Z direction. So we're not really doing anything analysis-wise in this case with any of these things. We are just taking a look at what it's going to do to our actual surface. So we are going to take a look and do that here. Now, one of the things to take note of with this is that when you have this type of data, it is a little bit larger. So the Hillshade or any of the functions that we are going to do are just going to take a little bit longer. So we just have to wait patiently for them as they run. And this is also going to be directly proportional to how good your things are in terms of your processor. So I'm just going to pause this and we'll come back as soon as it is done. Actually, looks like it's done here. So in this case, what do we got? There we go. So now we have this. So this is the 2012 one. So it looks like a bit of noise or a bit of a mess from up here. So one of the things you're going to want to do is you're actually going to want to zoom in to these to see what it kind of looks like. So this is the 2012 one. So you can kind of see what this is, what it's kind of looking like. And so from here, you're going to have to make some decisions about whether or not you think this is based on how this looks, right? So this is implying that light is coming from one side, right? And then if it's coming from this northeast direction, then what happens on the far side? So based on how this all looks, right, you're going to have to make some decisions about whether or not you think this is the true elevation based on what you know of Mississippi, or whether or not this is instead looking at the top of canopy, right? So is this the top of canopy? So is this a digital surface model, or is this a digital elevation model? Also take a look at this underground stuff and what's happening underwater and think about why those things might be different. So why might there be much more complexity above land than there is underneath the water when it comes to this type of analysis. Okay, so that is a Hillshade. You can repeat that process and take a look at the 2021 and see whether or not they look the same, how things look different, and all of that. So, but do make sure that you zoom into that and take a look at these different areas, see if you can, take a look at some of the roads, what that looks like, take a look at where it likely is going to be some of the houses. These look like subdivisions, right? So what's going on in this actual image, and then you can always turn it off and take a look at, again, what your actual elevation model looks like. So I'm going to stop this one here, and then we will come back and take a look